SwayamPrabha. Digital India. Educated India.
Okay, so we'll talk about another block cipher, which is called which is the Advanced Encryption Standard or AES. So can you please go to the slide? So far all the cryptographic algorithm we have looked so far has some problem, like we have seen the classical crypto system like SIP cipher, Caesar cipher. Those are earlier ciphers, so those are broken under the if we have modern computer speed, so those are not secured. Even we have looked at the DES, which is also broken by the generic attack, exhaustive search or time memory trade-off attack. This is by Electronics Founder Foundation. They made a hardware which can crack DES in less than 3 days and with the cost of this. So this is an exhaustive search attack. And also DES, on DES one can mount the non-generic attack like differential cryptanalysis, linear cryptanalysis, some variant of differential attack. Those attacks are there for DES. So DES is not secure. So so we need to have a alternate for the standard. So we tried with the triple DES. People tried with the triple DES. But triple DES is basically made from the DES itself, which is basically 3 times DES, 2 times encryption, 1 time decryption, and for decryption triple DES 2 time decryption, 1 time encryption. So each DES is a 16 round. So total round in the triple DES is 48 round, which is huge. So which will make our algorithm very slow. So then we and also DES is we have seen it is a problem with the block size. It is a 64-bit block, and so now we need a brand new encryption algorithm. We need a block cipher, new block cipher, which is supposed to be secure under the all existing attack. So what NIST did, so instead of developing a new cipher by themselves, what they did, they announced a competition, worldwide competition, and in that competition anybody can participate. So that was in 1997. So they announced a worldwide competition and they welcome all the cryptographers worldwide to submit their block cipher design. So those who are working on the block cipher or in crypto system, so they just jump into that competition and they design, and so this is the first and this they fix some requirement. This cipher, this submitted cipher should be well documented, unlike the DES, because DES we have we don't know where from these S boxes are coming. They have just given the table, it is a 4 by 16 table, but there is no really information how these data are coming. So they want, the NIST want a full documentation for the new design of block cipher. And so in the first round they got many submissions, and from that after first round they selected 15 algorithm were accepted. That means 15 algorithm, other algorithm was having some problem. So they even this was public, so anybody can see the algorithm and anybody can comment on this, anybody can attack on this. So that way it is open competition. So that is the 15 cipher was selected after first round. Then after further investigation, after further attack in the second year, at the second round, there was 5 cipher which was selected, and those names are basically Mars, Arshifo, Rindale, Serpent and Two-Face. So these are the cipher which was selected after the second round of this competition. Okay. So, again in the final round among this cipher, among these 5 cipher, finally the Rindel was selected. The name of the block cipher is Rindel, and this was selected because other cipher maybe people got some attacks on this, some faults maybe not well documented. So, finally this Rindel competed, I mean Rindel is the AES, the advanced encryption standard. Okay, so and this Rindel name came from the name of 2 cryptographers who designed this cipher. This is the 2 Belgium cryptographer, John Damian and the Vincent Richman. So, based on their name, it is the name of the cipher is basically Rindel. So, maybe this this is coming from say Richman 1% and Damian, sorry, DAEMEN. So, based on their name, Vincent Richman and John Romian. So, based on their name, they proposed this name Rindel. Okay. So, Rindel is a the AES which was make standardized in 2001 by NIST. So, now still now this is the AES, this is the standard for block cipher. Okay. So, basically it is a block cipher. So, it is a symmetric key primitives. So, but it is quite different than the DES, the earlier block cipher DES. So, how it is different from DES? DES was having key size 56 bit, effective key size. Now, here we have 3 variant of the Rindel. One is okay. So, Rindel has 3 version. So, this is basically a block cipher. This is Rindel or the AES. So, block size is 128 bit. So, this is a 128 bit. So, N is 128 bit block cipher. Block cipher. So, that means plain text and ciphertext size is 128 bit. This is ciphertext and this one is plain text. Okay. Now, the key size, there are 3 variant of this. One is 128 bit key, another variant is 192, another variant is 256. Now, depending on the key size, we have the number of rounds. For 128 bit key, we have R is the number of round is R is equal to 10 rounds. So, this is one version. Another version is if it is 192, then R is 12 round, and if it is 256, then R is 14 round. So, depending on the size of the key, we have the different round. So, these are called, depending on the size of the key, these are called AES 128, AES 192, AES 256. But in each of these cases, the N is fixed. It is a plain text and ciphertext size is basically 128, that is fixed. But only thing, we have 3 variant depending on the size of the key and the number of round. If the size of the key is 128, then the round is this version is called AES 128, and if the size of the key is 192, then the number of round is 12, and this version of AES is called AES 192, and this version of AES is called AES 256. Okay. So, among these, this is the most popular one because this has less number of rounds. So, it will be more efficient in the terms of computation. So, it will be little faster than others because others has more round, and the key size also less. So, if we can achieve the same level of security by using less key size, less number of round, then obviously that will be most popular. So, can you go to the slide please? So, the number of, so this is the thing. So, it depends on the this number of AES parameter depends on the key length. For example, the key size used is 128 bit, then the number of round is 10, which we have already discussed, and if the number of round is 12, then the key size must be 192, and if the number of round is 14, then this. So, among this most common key size is we take 128 bit. Okay. So, Rindell basically was designed to have the following characteristics. So, it must resist from the all known attack like generic attack, like linear attack, differential attack, all version of the differential attack, like boomerang attack. So, all these attacks. So, it should resist from the all known attack, and it should be fast. So, computationally it should be fast, speed and speed should be fast, and we should widely use, and the design should be simple. So, that will make the cipher fast. Okay. So, this following these characteristics it became the AES. Okay, this is a high level description of a typical R round AES. So, basically what we have a plain text X, and plain text is 128 bit. So, we will just store this plain text in a state. We will come to that how we can make the state, and then we have few operations. We have basically 4 operations. One is add round key. It is basically XORing, we take the input as a plain text, and it is basically taking the round key, and it is XORing with the round key, bitwise XORing, that is the add round key, very simple operation. And the other 3 operations are sub byte operation, this is the S box operation. So, we take a byte. So, this state, each state is a byte. So, we take a byte, and then we apply the S box, and then we get the output. So, that S box is taking a 8 bit input and giving us a 8 bit output. Okay. So, the operation basically first one is mixed add round key, so this is basically adding the round key. So, bitwise XORing the round key with the input. First input is the plain text, but later on intermediate value. Then the sub byte operation, this is basically S box. So, we have a 8 by 8 S box. We have 8 bit input, 8 bit output, and this is taking 8 bit means 1 byte. So, this is byte wise operation. So, we take a 8 bit and it will replace by a 8 bit. So, this is the sub byte operation, we will come to that AES sub byte operation, and then the shift row. Shift row, we are just basically shifting the row. We store the input in a matrix in a 4 by 4 state, which is called state. I will come to that how what is the state. Shift row and then mix column. Okay. So, these are the basic. So, we will also discuss what is the mix column. So, these are the basic operation we will use for designing the AES. So, these are the basic operations used in AES. Okay. And we will study each of this operation in details. Okay, so can you go to the slide please? Yeah, so this is the this is a typical R round AES. So first we take the plain text and we store it into a 4 by 4 matrix, and each entry is a byte, and then we perform the add round key operation. That is the first operation we will do, and then we will perform this sub byte operation, shift row operation, mix column operation, and again add round key operation. So this will continue for r minus 1 round, and then after that for the last round, so it is rth round, so r many round function are there. So in the last round what we do, we just apply the sub byte operation, shift row operation, add round key operation. So in the last round the mix column operation is missing. So basically this is the structure of AES. So we have the plain text X. So this we just first we add a round key, add round key, add round key. So for this we need a round key K1. Okay, and then we have r minus 1 round of this. So shift row, then sorry, this is sub byte. First one is sub byte, then the shift row, then mix column, and then again add round key. So for this add round key we need a round key. For next time it is K2. Okay, so this will repeat. So this is sort of one round function of AES. This will repeat r minus 1 times. So again this will be performed sub byte, shift row, mix column, add round key like this. Then after that for the last round what we do, we just apply sub byte, then shift row, and then mix column. Sorry, mix column is not there in the last round. So that is the difference. So add round key. So for last round we need to have, if it is r round AES, then we need to have kr plus 1, because we have used one round key in the first sort. Okay, so this is the ciphertext Y, and this is the plain text. So both are 128 bit. Okay, so this is a typical R round AES. So we have a 128 bit plain text, and finally we are getting a 128 bit. So this is the last round. This is the last round FR, and the first round is basically, this is the extra operation we are doing in the first round, but remaining after that we are just doing, this is one round operation. We are doing this for r minus 1 round, and then finally we are going to the last round. Okay, so we are now we want to discuss all these details, like what are these operation, add round key, shift row, mix column, like this. So let us just quickly talk about, this is the general structure, but we are looking at AES 128 bit, not AES 128, AES 128. So this version of AES we are looking for. So this is basically a 128 bit block cipher. So that means plain text and ciphertext size is 128 bit, and it has key size also 128 bit, and it has round is R is 10 round. So, it is basically a 10 round block cipher. So, what we are doing, this is our X, and we are first applying the add round key with the K1. Okay. So, then we are having this sub byte, then mixed sub byte, then shift row, mix column, and finally we have again a add round key. So, this is typically a 1 round AES, this 4 operation. So, this we need a K2. Okay. So, this is sort of first round F1, then again this we pass it to sub byte operation, then again shift row. Okay. So, then again mix column, then again a add round key. So, add round key. So, here we need a K2 like this. So, this will continue. This will continue how many times? So, this will continue 9 times. Okay. Again we will do the same thing over here. So, like this. So, for this we need to have a K3 like this. So, we will continue this 9 times, and for 9th we have a K10. So, same thing will continue. So, in the last round what we do, we have the mix column operation is missing. We are not doing the mix column in the last round. So, in the last round we are just doing sub byte, then shift row, and then just add round key, add round key, and here we need to have a round key which is K11. So, this is the ciphertext wise. So, this is a typical AES 128 bit block cipher. So, this is the plain text which is 128 bit, and this is the ciphertext. Okay. So, now we will discuss what are this operation basically, and how we can have this key serializing algorithm to get the round keys. Okay. So, basically, so now we will talk about AES is a byte wise operation. So, it is taking input in a state, it is state wise operation. So, state, it is a 4 by 4 matrix, we can just denote by S00, S01, S02, S03. So, this is the first row, S10, S11, S12, S13, S20, S21, S22, S23, S30, S31, S32, S33. So, this is basically a 4 by 4 matrix, and each of these is a 8 bit. So, it is a byte. So, each of this entry is a 8 bit. So, how we can take the input plain text in a state? So, our plain text is basically 128 bit, this is X, this is 128 bit. So, what we do? We divide into bytes. So, if we divide into bytes, basically we have 16 bytes. So, x1, x2, sorry, x1, x2, x3, x16. So, each xi is a byte or 8 bit. Okay. So, now what we do, we store this here. So, we take this like this. So, x1, x2, x3, x4. So, basically the first entry is x1, then column wise we are storing, then x5, x6, x7, x8, then x9, x10, x11, x12, then x13, x14, x15, x16. Okay. So, this way we will form the state, the matrix. So, we are just basically breaking the plain text into bytes, and each byte is a element of this entry of this matrix. So, this is a 4 by 4 matrix, this is called state, and AES is a this AES operation, the basic operation are state wise operation. Okay. So, now for the add round key, so add round key, what we are doing, we have a state basically, but this is again a 128 bit input, and suppose our key round key is also 128 bit. This is the round key, say kth round key, ith round key. So, add round key is basically bitwise XORing. So, this is a 1 0 1 like this, and this round key is say 0 1 1 like this. So, we are just doing bitwise XORing, this XOR with this 1, this XOR with this is 1, this XOR with this is 0. So, no carry, just a bitwise XORing. So, this is basically add round key operation. Okay, very simple operation, we are just XORing the, we are adding the round key, XORing the round key with the state. Okay. So, now we will talk about this sub byte operation. So, in a sub byte operation, yeah, can you go to the slide please? Okay. So, this is the state. In the sub byte operation, what it is taking? It is taking each byte, each entry is a byte. So, it is taking input 8 bit, and it is there is a table which is the S box table for AES, and it is doing the table lookup, and it is giving us the output. So, we have a S box which is a 8 bit input and can give us a 8 bit output. So, this is the sub byte operation for AES. So, basically we have AES box. So, this is the AES box. Okay. So, this 8 bit, so we can take this x, this is y, and xy are hexadecimal bit. So, this is given in the, this can be given in the table. Can you go to a slide please? Okay. So, this is the table for AES box. So, this is the x is an hexadecimal form, and this is the y. So, depending on the value x and y, we will go to that particular entry and we will get the output of the S box. So, suppose S is say x value is 8 and y value is 7. So, we will go to the this. So, output is C4. C is also in hexadecimal form. So, we have to convert into 4 bit, and 4 is also in hex form, we have to convert into 4 bit. So, these two will give us a 8 bit number. So, we have a 8 bit input and 8 bit output. So, this is the way we will just look at the table. So, we take a state, we take a entry of the state, that is a byte. So, this we will do the table lookup and we will convert that into phi of s. So, S00, S01, S02, S03, sorry, S12, S13, S20, S21, S22, S23, S30, S31, 3 2 S 3 3. So, this another sub byte operation, we take each of these and we replace by its S box. So, pi S of S 0 0, pi S of S 0 1 like this. So, in general for ijth element this is pi S of S ij. So, like this. So, we take a byte and we apply the S box, we got the again a 8 bit. So, that is the sub byte operation. But this AES sub byte is not just a table. So, there is some algebraic structure for this AES sub byte operation. We will talk about that in the next class, this algebraic structure, how we can get the, if we get a if we give a 8 bit input, how to get the 8 bit output. So, that is basically coming from the, we have to do some field operation there. So, we will talk about that. Now, let us talk about the shift row operation. So, in the shift row, AES shift row, yeah. So, this is the shift row operation. So, what we are doing? So, shift row operation for AES. Okay, so this is the state. Now, we are shifting the rows. So, this is first row will be remain unchanged, and second row we are shifting one time, circular shift. So, this is going there, this is going there, this is going here, this is coming here. Third row we are shifting twice, this third row, fourth row we are shifting thrice. So, this is the way we are doing. So, this first row remain unchanged, second row we are shifting one position, and this next row we are shifting 2 position, circular shift, and this row we are shifting 3 positions. So, that is the way we are shifting. So, this is the shift row operation, basically we are shifting the position of the byte. Okay. So, now we will talk about mixed column operation. So, mixed column operation will have the, so it is taking the column wise. So, S 0 0, S 0 1, S 0 2, S 0 3, S 1 0, S 1 1, S 1 2, S 1 3, S 2 0, S 2 1, S 3 0, S 3 2, S 3 3. So, in the mixed column operation, it is a column wise operation. So, it is taking each of this column and it is replacing by a new column. So, this may be S 0 0 dot plus S 0 0. So, S 2 0, S 3 0. Again it is taking a column and it is converting into a new column like this. 2 1. So, like this, again it is taking a new column, this column, and it is converting into a new column, S 2 0, S. So, this is the 2th column, 3 2, and then finally it is taking the last column, it is replacing by a new column. So, it is a column wise operation, but this operation involves some field operation. We will talk about this in the, so S 3 3. So, how this column is coming, the new column we will talk about in the next class. So, that is basically field operation we are doing, and then in the next class we will also discuss the this key scheduling algorithm, how we can get the round keys. We need 15, we need 11 round keys, K1, K2, K11, and each round keys is 128 bit. So, how we can get these round keys from the given secret key which is 128 bit, those we will discuss in the next class. Thank you.